Hi, my name is Tzu Lin, and I go by the name Jimmy. I'm a graduate student from the University of Florida Mechanical and Aerospace Engineering Department. I'm honored to have this internship opportunity at the Kennedy Space Center over the last 10 weeks. Over the next several minutes, I'm going to give you an overview and talk about some of the work that I've done during my internship at the Kennedy Space Center. The first things I worked on was to familiarize myself with the software called the Satellite Toolkit, also known as STK. This is a widely used software which you could specify different scenarios for your satellite. From here, I just want to show you a quick clip of a trivial scenario of a satellite with a typical antenna passing through US. The clip shows how the satellite simulates stars above the Washington state and with the ground station at Gainesville, Florida, and how the software is able to tell me what time during the day I can expect my satellite to come by, for how long, and what kind of signal quality I can expect from the satellite. The next thing I worked on was Microcontroller. I had the opportunity to attend a 5-day workshop with my mentor which focused on the use of microcontroller related development. Many of the things which this course focused on was the basic understanding of microcontroller, how to make sense of data sheet and how to use it toward your advantage, as well as many of the ways to use microcontroller to interface with many of the useful devices such as accelerometer, real-time clock, wireless communication, and temperature sensors. Those are just a few examples. And with the need of automation and a world that is becoming more technology driven, I believe this will remain a skill of a lifetime. And just to give you a little bit of what I worked on, here we have two development boards. Each has one microcontroller connected to it and one what's known as the Zigbee wireless chip connected to it, represented by the red chip. Now the goal of the project is to make the two development boards talk to each other via the wireless chip. Part of the project was to demonstrate that you can press a button on one board which will cause the LED lights on the other board to react. So as I hold down the button, you'll see the fourth light from the right will lit up. As I let go, you'll see the light will dim away. And this particular procedure is communicated through the wireless Zigbee chip. Also, as another part of the project is that this board on my right has to be able to sample temperature and transmit the information to this board, which then display on the computer. So now, by sampling the temperature, as you can see, the current temperature in the room is 75.3 degrees. Well, this temperature is sampled by this particular board on my right and transferred to this board to my left. And here are just some of the things that I worked on. Last but not least, I have also been working with a group of NASA engineers to mentor a group of high school students from Merritt Island High School on the development of CubeSat. The goal of this project is for us to guide and teach the student how to approach the initial design and build phase in a systematic manner. It has been a joy working with the students, and I hope they have learned as much from me as I have from them on this project. Lastly, I just want to thank my mentor Richard Burr, NASA KSC Education Office, and Florida Space Grant Consortium for this once-in-a-lifetime opportunity to be out at KSC, not only during the summer, but also during the last voyage of the Space Shuttle program. Thank you for everything I have learned and the opportunity to witness the end of the Space Shuttle program and be part of a great history. I certainly wish to pursue any future internship and co-op opportunity from NASA. Thank you.